All right, in studio, we are honored to have Curtis from Hathaway with us today. How are you?
I'm doing good. How are you?
Excellent, thank you. So, Curtis, what is your role at Hathaway?
My title is I'm the Chief Operating Officer for Hathaway. We're a small independent oil and gas producer.
Okay, good. I was going to say, because a lot of kids out there may not know what Hathaway is, but we all know it's involved with oil.
Yes.
And how long have you been with the company?
Just over 8 years.
Okay, and how did you get started? I mean, were you always in this industry, oil, or was it something that you kind of fell into?
Originally, I went to college in Michigan. I got my degree in mathematics. I worked in the automotive industry for 2.5, 3 years. Before I went to school in Michigan, I played football at BC. I'm a Bakersfield boy.
Okay.
And my kicking coach at BC was Chad Hathaway, the owner of Hathaway LLC.
Oh, right, yeah.
And 2 years into my career, I was talking with him, and I didn't really like the corporate organization, didn't really like the corporate feel. And so he asked me if I wanted to come work for him in a small company, and the rest is history.
Good. So Chad knows how to kick?
Yep, he kicked at
So if he was
BC
the
and
coach,
Fresno
then-
State. Yep.
Okay. So you're Bakersfield boy.
Yes, sir.
But then you went Big Blue.
Central Michigan.
Oh, okay.
Chippewa.
So you went
Yes,
to
sir.
Michigan. Okay. All right. So you're still in Michigan.
Yes, sir.
So you're not, but do you despise Big Blue?
No, whatever.
Yeah, cool. All right. Because I was going to say, if you were
know.
like, yeah, Big Blue all the way, we got Wisconsin people in here. Not myself.
Yeah.
I was just going to say we can deal with that later on. But anyway, all right. So you're with Hathaway, and you've got a pretty important gig there. So let's talk about what you're going to be showing the kids today.
Okay, yeah, what I brought today is I wanted to go through just some basics of math and how it's used every day in the oil fields. So what we're going to go through today is well testing. And what I mean by well testing is checking what a well makes, how much oil, how much water, how much gas. So first here we have a basic diagram of a simple formation, and if you see the red here that means there's a confining layer that is holding the oil and the water and the gas underneath the earth. And what you do is you have a well that penetrates down into the formation that has gas, oil, and water. And then as that well pumps, the oil, the gas, and the water all come up to surface through what is called the tubing and the wellbore.
Now, before you keep going, because a lot of students are going to see wells like that. So is that a sucker pump?
Yeah, this is a rod pump, yes, correct.
Okay.
Yep, they're all over Kern County, and in Kern County, they're everywhere from 500 foot deep to 10,000, 15,000 feet deep.
And is there somebody at Hathaway that determines how deep you guys have to go and testing that stuff first?
Yes, usually that's the work of a geologist.
Okay.
So that's what geologists do, is they determine where the oil is, where we want to drill to, where we want to put the holes in the ground.
All right.
So as a well is producing, one of the most important things is you want to know how much oil the well is making. So what you do is you have what's called a ball trap or a test trap, and this picture here on the right is the picture of a test trap hooked up to a well. And the way that test trap works is all of the oil, water, and gas flow into that trap. The gas is what is lighter, so the gas rises to the top, and then the gas will be then released back in through a gas system, and the oil and the water will fall to the bottom, and the oil and the water will then be metered. So then as I go to the next slide, you see here, this is an example of the meter. So as the oil and the water flow through the line, there's a meter that spins and will give you a reading. And there we get into how you test the well. So I put in an example. So to test the well, what you look at is your gross flow. So you look at what does this meter start at, what is the stop time, and then so the meter start, the meter stop, and then what time did you start and what time did you stop. So I'll go through the first example. The first example is my meter. I start my meter, it's at 0 barrels. The BBL means barrels. And then I'm starting this test on this well at 2 p.m. And then my meter stop is at 4 p.m. and I have 13.5 barrels that have passed through this meter. And so as I go through this, everything is always done in what is called a 24-hour gross. So we know what is production for one full day. So if I take that math formula, I'm going to say the meter had a change of 13.5 minus 0, which is 13.5 barrels. And then over the span, if I do 2 divided by 24, because there are 2 hours, 2 hour long test in a 24-hour day, gives me 13.5 times 12, which gives me a rate of 162 barrels per day.
And that's if it's continuously flowing though, correct?
Correct. That is if the well is continuously flowing. So if you have a well that starts and stops all throughout the day, then you will extend the time period of that test.
Okay.
So if a well is turning on and off often, then you will usually do that test for the full 24 hours or 25 or 26 hours to make sure you capture all that time.
So what would be an instance where it would have to go longer than that?
Longer than?
The 24 hours. So what would happen, like what would cause that to have to go longer?
Normally what would cause the longer than 24-hour test would be if you have something new happening to a well, if it's a new drill, or if a well has had a new zone or something opened up to it, or if it's responding to what's a water flood or a steam flood, some sort of external force. And so then that well's gross is constantly changing. So then you would want to be testing it more than 24 hours or testing it frequently, test it for 24 hours and then take a break and then come back a few days later and test again.
Okay.
Correct. So the second example, same formula, just the numbers get a little bit more complicated as you change in different times because as what is called a lease operator, who's the person who does these testing, as their day goes, they don't exactly time up when they're going to check their meters because at any given time, the person who's doing this is testing multiple wells, they're checking multiple facilities throughout their day. So in this example, we have a meter that has a start date of 13,453.2 barrels at 7 p.m., so at the end of the day, and then they come back the next morning at 4:15 in the morning, or someone else comes back the next morning and they have a meter stop of 16,738.1 barrels. So then same math, the first thing we check is what is the difference in the meter change, which is 3,284.8 barrels. And then now the great example on the fractions that you guys had on the show, this works out perfectly. You take the time, you have 9.25 because it was 9 hours and 15 minutes, so that's a quarter of an hour divided by 24 hours, gives you end result of 1,264.6 barrels per day.
All right, so quite a bit more production than the other one.
Yeah, correct. And so then the next step is now we have calculated what the total flow of that well is. So now we want to specifically focus on how much oil and how much water. So from that well, you will grab a sample of the fluid. There's a continuous sample or a same sample, and you will take that sample and you will heat it up and let the oil and the water separate. From the oil and the water separating, you will then go and measure how much is oil and how much water to get a cut. So for this example, I have 100 milliliters in this of water and 550 milliliters of oil if I'm using this as my oil level point, which normally you look down on top and you'll be able to see and get rid of this inference. And with that being said, then I do a 100 divided by 550 gives me the 18.2%, which is my water cut. And then if you take the inverse of that to make it a whole, 1 minus 18.2 gives you a 81.8% oil cut.
I'm glad you mentioned that as far as looking down at the top and then taking those measurements, because a lot of times when you have liquid in a container, it's kind of just a little bit of that little slope on that edges right there because of the adherence to the container itself. So that is important to take.
And then in the San Joaquin Valley, we have a lot of heavy crude, so this is a very common thing of where the oil is going to get stuck and it's going to be heavier and be harder to read. So it's very important that you're looking down at the top and seeing exactly where that.
All right.
And then the final step of you test this well, you figure out how much oil it makes. You want to know, well, you have to test that accuracy of that well. So in this example I have here, I have 4 wells, and these 4 wells go to one specific facility. So in that well, we test all 4 of these wells. You can see here, you have well 1, 2, 3, 4, and each of them have their calculated test. BOD is barrels of oil per day. So each one is their barrels of oil per day. They all go in and they run into what is called a wash tank, where the oil and the water are separated. The oil then goes to get sold. The water then goes back to injection. So in the course of one whole month, I look and I say from this particular facility, I sold 1,176 barrels of oil, right? And I also look at how much oil was in this tank at the beginning of the month and the end of the month. And so in the course of 1 month, we went from 70 barrels to 78 barrels, which gives us a difference of we left 8 barrels behind. That means in the course of a month, these 4 wells, 1,176 plus 8 gives you 1,184 barrels of oil sold, which gives us 38 barrels of oil per day if you take 1,184 divided by 30, right? So now, if I look back, I have our well tests, which gives us 39.6 barrels of oil per day. So I need to check what our well testing accuracy is. And so simply by looking at the 39.6 into the 38 gives you a 96% testing accuracy.
And is that kind of where you are usually, or is there a minimum you guys got to make sure in order to keep those wells going?
Correct. So the biggest thing is you look at the individual economics of every well. But when you do those well tests, you need to say, does the well test that was calculated match the oil that's been sold, right? So you want to look at your well testing accuracy. So that operator constantly wants to see that, ensure the industry standard is that I'm a 95% accurate. So I know that when that 13.2 barrels a day for well number 1, that it is accurate because it matches the oil that's been sold.
And I know you've got a little bit about Kepler coming up on your last slide, right?
Oh, yeah, yep. And then I get to my last slide. So having a degree in math, I put my very last slide. So my favorite mathematician is Johannes Kepler. He is famous for his 3 laws of planetary motion, which were instrumental in understanding the universe we live in, and space travel, and a lot of mathematics and geometry. And it is extremely impressive that someone who was living in the 15th century was able to look through a telescope and determine that our Earth is not traveling in a circle, it's traveling in an ellipse. And there's 2 foci in between the sun and another foci point that exists. It's pretty mind-blowing to see.
Right, especially back then.
Yeah, correct. Where there's no power, Columbus hasn't sailed across the ocean, and he just looks up in the sky and figures it out.
All right. Well, you know what? We certainly do appreciate your time coming in to visit us here on Do the Math. And when you see Chad next time, what I want you to do is let him know that you were a guest on Do the Math with the new set in place. All right.
Okay.
This is our 23rd season. And for coming in, we'd like to give you one of the pins, and make sure you wear that. You wear it prominently so when Chad sees it, he's like, hey, dude, where you get that right there? All right.
Will do.
All right. Curtis, thank you for coming in
much.
once again. And we'll be back with more right after this.